Okay, this is now the first example that we are going to look at. It's an example of independence of association. So maybe what I'll suggest is that we pause the video this time. Make sure that we read the question. It's also in our textbooks. Just pause the video, read the question, and when we come back, we'll start solving it. So the question will no longer be available here, but you can look at it in your textbook. What I'll keep for most of the time will be this table here because we will need it to perform further experiment. All right. Well, welcome back. We are still doing example. I'm just gonna write it here. Example 10.1 of the Teenage Magazine Preference Study. After reading, let's just understand the research or management question. I'm just gonna write it management Q. So what we're being asked here is our readership preferences for the three, I'm just writing magazine independent of gender. This is what we need to find out, and we are testing it. The test is being performed at 5% level of significance. What are our variables here? We have two categorical random variable. The first one being gender, that I'm going to put here, male and female. And we have the second variable, which is magazine. I'm just gonna write mag, and in the day we have beat, youth, and girl. And all our observations have been represented here. Keep your eye on this table. That's what we're going to use most of the time. Let's now make some space now that we understand what we are being asked. Like I said, this follows the same steps that we've been doing, just with a few things that will change. What will not change is step 1. Define the null and alternative hypothesis. If you remember, just on the side, I'm going to show you, I've always said that the null always carries the equal sign, right? And here we will represent it as like this, but it still has the equal sign. So equal sign, that means that things are the same, or also no difference. You would agree with me. Therefore, my null here will be there is no association between gender and magazine. I'm just write magazine preferences. And my alternative will tell me now that there is an association. association. If I have to represent it using those signs, I would just say here I'll represent it in this way. Let's look at it. I'll write it, let's say I'll say gender, you know, the preference is equally with for boys and girls, you know, or males and female, as the same for all the magazine preference. And here I would say gender M and female, there's actually a difference, you know. That's why the sign here between the magazine preference, something like this, because we know that we are dealing with a one-sided Apatow hypothesis test. So meaning that choosing actually the null hypothesis will tell us that the preference are actually the same. Its gender have the same preference across all the magazine, and then taking the alternative will tell us now that it differs. There's a difference between the genders and the magazine preference. Now we will just make some space here and go to our second step. Okay, I deleted some of the. Now let's go to step 2 to determine the region of acceptance. For the independence test and equity, the formula for the degree of freedom is equal to rho minus 1 bracket column minus 1 as well. Okay, and here, looking at our data, you'd see that how many rows do we have? We have 2 rows, male and female, and the columns, so row 2, and the columns we have 3, so 1, 2, 3. Don't count the total, obviously. Then we'll write it in this manner: 2 minus 1 times 3 minus 1, which is equal to 2. And then what we'll do is that we have to go now to our table, which I brought for us here. Table 3 to the back of your textbook. And let's find what's with the alpha, because by now you should know 5% is an alpha of 0.05. And what's in the alpha of 0.05 and the degree of freedom of 2 gives us, it's this one here. Hopefully you can read that. Let me just maybe I'll just point it out like this. Okay, so what we have here is our chi-square test. So I'm gonna write with this color. Maybe let me just keep it right on top here. That was a perfect XD. So our chi-square test here is, as you can see, 5.991. So that is our chi-square limit, I would say. Sorry, chi-square limit with those coordinates. Then what you would tell me is that you accept the null if your chi-square stat lies below or at that value, and that you're going to reject the chi-square stat lies above this. So remember that. Now we are going to go to the fun part where we need to draw all those tables and then apply all those formula. It's very simple, but will just require your focus and your attention. So let's go to the fun part. Welcome to step 3 now, which is calculating the S stat. Like I said in the beginning, the first step that we need to do is to work out the expected frequency, because from this table here, what we are given is the observed. So what has been observed on the field, wherever the calculation were made, but now we need to compare them with the expected one, and this is the formula. It's very simple. The first thing that you do to perform this is to rewrite your total, because this formula is actually telling you that you do the ith row total times the column total, and you divide it by the total sample size. So you look at whatever row total you have and whatever column total you have, then you divide it by the sample size, which is going to be here. So just follow with me. I'm going to do 102, then I'm going to pause and then let you do the rest while I'm also doing the rest. Then we'll compare our result. The first thing that I'll preferably want to do is to rewrite the total. So the female row is 180 here, 120, then we have 200, and the column, the beat column, is 46, 73, 81, and the total here also we should get 200. Now here's what you need to do. So I'm just gonna write expected frequency, let's say for female and beat. Female and beat. What you will do now, you take the total, the row total of female, the row total of female, which is 80, you do times the column total, which is beat, which is 46, and you divide that by the sample size, which is 200. Now just take your calculator and tell me what you find there. So where you have female and beat, and you see that the row total that you would get here should be 18.4. 18.4. Now what you are going to do is just write it up here. Okay. 18.4, and let's do just another one. Then maybe let's see now male and beat. So for male and beat, I'm going to do the same thing. So when I have male beat is equal to 120 times 46 divided by 200, which should be equal to 27.6. Then I'm gonna put 27.6 here, and maybe a last one with a female and grow, the magazine grow. I would have female and grow. I would have 80 times 81. So row total, column total divided by sample size, and you divide it by that, then you see 32.4. So female and grow 32.4. Now feel free to pause this video at any time from now, which is also what I'm going to do, and perform the remaining 3, and we'll compare our result at the end. I want you to practice that. Take your piece of paper and your calculator and do that. Well, as you can see, you probably got these answers, so that was easier than you may have anticipated. That this is how you work it out. Feel free to pause this video anytime if you didn't get that, or if I went faster. Then after you have this table, now we should be able to move into our XStat formula, which I'm going to clean this data and leave these 2 here so that we can calculate those XStat. Well, now we've arrived to, I think, the easiest part of our exercise, because now all you have to do is to create a similar table like this every time that you perform this. And first we write the value that you already have, then from there you should be able to calculate individually this column here until you give us the grand XStat total here. So let me just write that one. I didn't add it. XStat, then you put the total from this column here. The formula is here. So XStat, chi-square stat, sorry, not XStat, chi-square stat, it's the sum of all the observed frequency minus the expected frequency squared divided by the expected frequency. So what you have to do is to plot out all your observed frequency with the matching expected frequency for each of these categories. Then you square them here. After you square them, what you do, you divide them now by this expected. Again, you put all those values here, then you add those up. So I'm just going to pause the video at this point to write all my observed and my expected categories, and then I'm going to show you how this is done for the first 2, then you do the rest, and as well as how this is done for the first 2, then we'll meet here with our final answer. Take your time now, just pause this video, take a piece of paper if you didn't already, and a calculator to do this with me. Okay, now that I've just written, all I just did here, I took this value and this value here, I've just placed them together. That's all I did, nothing more. Let me just show you what you need to put here. So what I'll do here, I'll do 13 minus 18.4, and the answer that I get is squared. So that should give me 29.16. Then I'm going to write it here, 29.16. Then I'm going to take again 28 minus 29.2. I put those in brackets, square the answer. This is going to give me 1.44. Then I'll do 1.44. Now it's your turn to do the rest. We'll meet here. Okay, now I'm certain that you got the same answers here. For the next step, what I will do, because I already have this one, the top part, I will just do this. 29.16, I divide it by 18.4, and this should give me 1. This time now I'm gonna take more decimals, so do not freak out if you see that some of your decimals are not the same with mine. It depends on how many decimals you considered here. If you considered more, it should change a little, but not a lot. We will more or less just get the same answer in the end. And here for this one, this is what I'm going to do, 1.44, and I'll divide it by 29.2, and this should give me something along this 0.49, and I'm going to write it here. Okay, so yeah, 0.049. So now what you need to do is pause again so that you can actually do the rest and write the final grand total here. So we are meeting here in the next few minutes. Best of luck. Okay, so if you did the right thing, you should get this answer or something closer here with a few decimal number that differs. Now, well done, and we can move to our fourth step now, which is the statistical conclusion, and step 5, which will be the management conclusion. Okay. Coming now to step 4, I'll just rewrite what we say, that we will accept the null hypothesis if our chi-square crate or chi-square stat, chi-square stat here was less than or equal to 5991, and we were going to reject the null hypothesis if the chi-square stat was greater than this value. And as we can see there, that the sample test statistic, our chi-square stat of 4.964 lies within the ROA, region of acceptance, of what we said here earlier. Therefore, we will accept the null hypothesis at the 5% level of significance, and this means that the SE sample evidence is not strong enough to reject the null hypothesis in favor of the alternative. For now, our step 5, statistical conclusion, I will not write everything, but I can just tell you, I'll just speak it out. What we'll do is that we can conclude with 95% confidence that, what are we concluding here? That magazine preference is independent of gender. Or also alternatively, I'll say that there is no association between the two.